Hi everyone, my name is Haozhe, a PhD student from Carnegie Mellon University. I'm excited to present our paper, Bring Privacy to the Table, Interactive Negotiation for Privacy Settings of Shared Sensing Devices. Today, sensor-equipped smart devices have become more and more prevalent. Some of examples include smart cameras, smart speakers, motion sensors, and smart door locks. While bringing various benefits, they also impose significant privacy risks because they can measure and collect a wide array of data, including voice, facial features, and identity. Especially, a key challenge is associated with devices placed in shared environments. Such environments have multiple users, and the sensed information is not limited to that of the owner or the person deploying the sensor. Instead, anyone who happens to be in the same physical space gets captured. Several prior works have pointed out that incidental users and bystanders face limitations to become aware of the devices, express their privacy preferences, or have control over the data collection. This tension becomes more challenging to resolve when multiple stakeholders have conflicting preference. To better understand the situation, let's consider a scenario where Bob and Charlie are visiting Alice's home for a party. Alice has a smart speaker in her home and she really wants the voice commands features. However, Bob feels strongly concerned about a constantly listening device, whereas Charlie is more flexible but really hopes everyone is comfortable. The above represents a very simplified scenario where multiple stakeholders may have conflicting preference on the privacy configurations of Alice's smart speaker. One may naturally come to how human beings usually resolve conflicts among groups and settle with an agreement. Negotiation. Indeed, a good negotiation can not only resolve the conflicts but also potentially strengthening the social connection. And the form of final agreement can also be used as an affirmative consent to allow data collection on each participating users. But the question is, how should we build the system? To answer this question, we followed a human-centered iterative design process. First, we conduct an observation study on 12 participants. We arrange participants into a group of three to verbally negotiate privacy settings of shared devices freely, from which we observe different types of negotiation interactions and the potential factors that may affect the negotiation dynamics. Next, we consolidate our design implications from prior research along with our findings from participants' observation into high-level design decisions. We envision a system-mediated, structured negotiation system featured which continuously updating user preference model and contextualized negotiation prompts. After that, we built our negotiation system, ThingPoll, that empowers incidental users to interactively negotiate the privacy settings of IoT devices. Finally, we conducted our second user study to evaluate ThingPoll along with the baseline approaches with 30 participants. Next, we describe in more detail of ThingPoll, our proposed interactive negotiation system for shared sensing devices. Aiming for efficient conflict resolution and maximizing the joint gain of all stakeholders. ThingPoll strategically estimates and solicits preference from each user, mediates the negotiation process towards conflict resolution by suggesting likely acceptable configurations. The process of making privacy decisions can be exhausting for the users as they have to navigate technical intricacies with the additional social pressure every time they enter a shared IoT space. To relieve this effort from users, ThingPoll extends the idea of privacy profiles and predicts user preference on privacy configurations as well as how likely a user is willing to make a concession. ThingPoll assigns each user to an initial preference profile based on a total of 6 questions on 3 hypothetical shared device scenarios. This is powered by a Bayesian network model built from crowdsourced survey data of privacy preferences from 198 Mechanical Turk workers. Now, coming back to the scenario we described earlier, assuming all users registered ThingPoll and created an initial profile, they can now pull out their phone and join the negotiation session on ThingPoll to find an agreement on privacy settings of Alice smart speaker. First, ThingPoll asks all users to rate the importance of each functionalities of the device, from very unimportant to very important. Let's assume Alice thinks the voice command functionality is important. Bob and Charlie selected unimportant and neutral respectively. This step not only allows ThingPoll to prioritize the important functionalities, but also serve as an anchor that describes who is the beneficiary user for the following privacy-related discussion. Next, ThingPoll strategically balances exploration and exploitation. When ThingPoll is less confident of what might be a good configuration based on its current preference estimation, it will send the queries to specific users. In this case, ThingPoll asked Bob if he feels comfortable to enable an always-on audio data collection, as Alice indicated it is important to use voice command for music playback control. Let's say Bob might have a strong opinion and does not want to concede, so he selected very uncomfortable. Now, the query moves to the other users and becomes a functionality query, which asks these users whether they are okay to give up this functionality given Bob is not comfortable with the always-on audio data collection. If any user still does not want to give up this functionality, this query bounces back to Bob and will continue this manner until anyone concedes. For simplicity of illustration, let's say in this situation, Alice and Charlie both understood Bob's concern and made a concession to disable this functionality. Through querying, ThingPoll had refined its estimation of each user's preference and thus proposed a configuration. ThingPoll displays configuration in IoT privacy nutrition label, which is a succinct way of displaying IoT privacy specification carried out by several prior research. In this case, the configuration suggested a less invasive option, which states only collecting data when pressing a physical button instead of an always-on listening setting. If all users select yes, then their negotiation reached an agreement. The agreed configuration is then applied to Alice's smart speaker temporarily during their party. We evaluated ThingPoll through a user study of 30 participants, where it ranged participants into a group of 3, where one participant plays the role of homeowner and the other 2 participants play guests. Each user consecutively negotiates on 4 sensor devices of various types and number of functionalities. Through this study, we demonstrated that ThingPoll is effective in helping multiple users reach an agreement on privacy settings. We found 97.5% agreement rate, with only 1 out of 40 scenarios did not yield an agreement due to an unresolvable conflict between the homeowner and one guest user. Each group spent on average 196 seconds to complete negotiation on one device. If excluding the waiting time on other users, each participant on average spent 93 seconds in processing the information and responding to ThingPoll. Finally, each user receives 1.4 queries and 1.6 configurations per device, implying ThingPoll efficiently elicits user preference and suggests likely acceptable configurations. We also analyzed the negotiation outcomes. Among the agreed scenarios, we found guests were initially uncomfortable with 43.6% of the functionalities enabled by the homeowner. This indicated a critical need to account for incidental users' privacy concerns. Through negotiation, 73.5% of those were agreed to turn off or turn to less invasive options. For the other 26.5%, guest users made a concession and agreed to keep the functionalities on. We compared outcome satisfaction from negotiation using ThingPoll against 3 baseline approaches. The majority vote approach takes the majority preference of the group. The veto vote approach is the most strict policy that turns off the functionality if any user is uncomfortable. Finally, the homeowner preference approach simply applies the homeowner's preferred configuration without considering guest preferences. The negotiation approach using ThingPoll yields 83.3% overall satisfaction, noticeably higher than the three baseline approaches. As one participant stated, ThingPoll reduces the inertia to express their needs and respects everyone's preference. As the landscape of smart home devices continues to grow, we envision ThingPoll as a pioneering tool paving the way for negotiation-based approaches to multi-user IoT privacy management. In conclusion, we presented our pathway to developing an interactive negotiation system, ThingPoll. ThingPoll mediates the negotiation of multiple users and is demonstrated to help users reach an agreement quickly with high satisfaction. In the near future, we believe there will be a harmonious and privacy-aware environments for both owners of devices and incidental users. If you are interested in knowing more, please check out our paper where we discuss in details of our design implications, findings on users' needs and behaviors, profile and negotiation model, potential future directions, and more.